Good evening, students.
Good evening.
Recording in progress.
So, are you able to see my screen?
Yes, sir.
So, now we'll get started with the next chapter. Okay, that is gravitation. Okay, this is something you have already learned in your 9th grade. Yes. So, in this chapter, what we are going to discuss is we are going to discuss about what is gravitation, what is gravity, and then we will be deriving certain expressions for a parameter called as acceleration due to gravity at different points. Okay, so that is what we are going to do now. Right. So, having said this, shall we get started? Yeah.
Yes, sir.
So, the first point that we need to understand is what is the difference between gravitation and gravity. Okay. So, both the terms seem to be similar, but they are not. Right. So, if you observe, when you talk about gravitation, right? So, when you talk about gravitation, it says everybody in the universe, right? When you take different objects that are present in the universe, they always attract each other, right? Attract each other with a force called as the force of gravitation, right? So, from this, if we see, gravitation is basically the force of attraction that is existing between any two bodies in the universe, right? So if the force of attraction is existing between any two bodies in the universe, you call that force as gravitation. So basically, gravitation is force only. What force is that? It's an attractive force that is existing between the different particles present in the universe. Am I clear with this? Am I clear or not, guys? Waiting for your response.
Yes, sir.
Okay, then what is gravity? So now we need to understand what exactly is gravity all about, right? So let's see what it is. So the attraction between sun and earth, the attraction between table and chair lying in a room, etc., are all examples of gravitation. So if you see, gravitation is considered to be the weakest among all the four basic forces in nature. What are the four basic forces that we have? What are the four basic forces we have? Gravitational force, electromagnetic force, strong nuclear force, and weak nuclear force. So all these are the basic, the fundamental forces that are present in the nature, right? Okay. So if the attraction is taking place, right? If the attraction is taking place between the bodies in the earth, then you call that gravitational force as gravity. Okay. So what is gravity? Gravity is the force of attraction between earth and any object lying on or near its surface. Right. So generally what happens when you throw an object upwards, it is going to come back downwards due to the gravity. Right. So this is what we call it as gravity and gravitation. So it's a very simple concept. With the hope that you're clear with this, I'll proceed to the next concept. Shall I?
Yes, sir.
Yes, sir.
Okay. The next question is acceleration due to gravity and weight of a body. Right. So we know what is the term free fall means. Right. What does a free fall mean? If an object is traveling under the influence of gravity alone. Right. What is it? If an object is traveling under the influence of gravity alone, we call that kind of motion as free fall. So if we neglect the resistance or friction offered by air, right, the fall of the body in the air is said to be free fall. Right.
Yes.
Yes. So we have done problems based on free fall. That is when an object is dropped and it travels under the influence of gravity. Projectile motion, right? When an object is projected at an angle theta with respect to the horizontal, this is also an example of free fall because the object is traveling under the influence of gravity, right? So this is all about free fall. And the next concept is what is meant by acceleration due to gravity. This we had been using in almost all the chapters till now. So the small g is called as the acceleration due to gravity and its value is 9.8 meters per second square, or it is also taken as 10 meter per second square. Right. So what is acceleration due to gravity? When an object falls freely towards the surface of the earth, its velocity continuously increases, accepted because if I take this to be the surface, if an object is dropped from here, its velocity is observed to be increasing as it progresses towards the surface of the earth, right? So acceleration developed in this kind of a motion is called as the acceleration due to gravity, right? And how is it denoted? It is denoted by the symbol G. Right, let me change the color. Yeah. So it is a vector having direction towards the center of the earth. Right. How is it directed? Acceleration due to gravity is always directed towards the center of the earth. And most importantly, it does not depend on the mass, size, and shape of the object. Whatever is the shape, size, and mass of the object, the acceleration due to gravity is always a constant at a given place. However, it varies from place to place on the surface of the earth. So when I say it varies from place to place, what are all the parameters on which it is going to be dependent on? It depends on the altitude, depth, rotation of the earth, and shape of the earth. So these are all the parameters that come into consideration for this acceleration due to gravity to change from place to place. Is it clear? No.
Yeah.
Next is what is meant by weight of the object. Weight is also another concept we had been discussing the previous chapters, right? So if m is the mass of a block, then the force with which the earth is trying to pull the object towards itself, right? So weight of the body is the measure of the gravitational pull exerted by the earth upon it, right? So weight of the force is defined as the gravitational force with which a body is attracted towards the center of the earth, right? So you know how to calculate the weight of the object. If m is the mass of the object, mass multiplied with the acceleration due to gravity is going to give the weight of the object. So W is equal to mg, right? The next question is, Newton's universal law of gravitation, right? So one day in the year 1665, you know all the story, right? This apple fell down and everything, and Newton asked a question of why this is traveling in the downward direction, right? So by doing and observing all these parameters, he came up with a law which states something like this. So Newton's law of gravitation states something like this. Every particle, please make a note. I want everybody to write it. So every particle in this universe attracts every other particle with a force. So every particle in the universe attracts every other particle with a force which is directly proportional to the product of their masses. So if I have 2 point masses m1 and m2 separated by a distance r, then the force is observed to be directly proportional to m1 into m2, and it is observed to be inversely proportional to the square of the distance of separation between them. So when you combine both, F will be directly proportional to m1 into m2 divided by r square, or F will be equal to G into m1 m2 divided by r square, right? So I repeat the statement. Every particle in the universe attracts. So gravitational force is always an attractive force. Please have this in your mind, right? In the universe attracts every other particle with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Okay. And when you write it mathematically, you get F is equal to capital G into m1 m2 divided by r square, where capital G is going to be the universal gravitational constant, right? M1 and M2 are going to be the mass of the particles that are participating in this particular process. And R is going to be the distance of separation between those two particles. And please make a note that the value of capital G is going to be equal to, the value of capital G will be equal to 6.67 into 10 power minus 11 Newton meter square per kilogram square. Okay. Now, if you see this capital G, it is a universal constant, meaning the value of capital G does not vary from planet to planet. It is going to be the same everywhere. Whereas if you look at small g, the small g is called as the acceleration due to gravity. But acceleration due to gravity changes from place to place, right? Now, the next question that we need to answer is, what is going to be the dimensional formula or dimensional formula for capital G? So how do we calculate it? So how do we calculate the dimensional formula? It is calculated like this. Newton meter square per kilogram square is okay. So for Newton, what is going to be the dimensional formula? ml t minus 2 into dimensional formula of mass is m square. Sorry, Newton meter square. No, that is length. Sorry. So length square divided by kilogram is measured in mass, so mass square. So what is going to be the answer? M minus 1 L cube T minus 2. So M minus 1 L cube T minus 2 is going to be the dimensional formula of acceleration due to of the universal gravitational constant. Okay. Shall I proceed?
Yes, sir.
Okay. The next concept is vector form of the law of gravitation. Okay. Suppose I have mass m1 here, mass m2 here, which are separated by distance r. Okay. Now, if I take the attractive force experienced by the first particle, I will write it as F12. If I calculate the attractive force experienced by the second particle, I'll write it as F21, and both are going to be vector quantities. Right. Now, if you see, listen to this carefully. I'm going to explain it in detail. Make a note of this. So, if there are two particles of masses m1 and m2, which are present at distance r1 and r2 like this. So let's say r1 is the position vector of m1 and r2 is the position vector of m2. Okay, if I join these two, right, if I join these two, then what am I going to get? I'll get AB. So if I take a free body diagram like this, if this is going to be R1 and this is AB and this is going to be R2. Okay. Then tell me what is AB vector in terms of R1 vector and R2 vector? Tell me what is AB vector in terms of R1 vector and R2 vector. Can I write R1 vector plus AB vector is equal to R2 vector? Which implies AB vector is equal to R2 vector minus R1 vector, or this can also be written as R21 vector, or this can be R21 cap. Okay. Is that point clear?
Yes, sir.
Good. Make a note of this.
Sir, why are we writing it R21 cap? Is it a unit vector?
Which one? Direction is R21 cap. I'm saying the direction is given by R21 cap. If it is a unit, I'm not saying it is a unit vector. Direction is this thing. Okay, just to clear your doubt, R21 vector is equal to magnitude of R21 vector into R21 cap.
Okay, sir.
Okay. Shall I proceed? So this is the case. Now, if you see the particle at A will experience the force in this direction. It is F12 as a vector. So what will be the value of F12 vector? F12 vector will be equal to G M1 M2 divided by R square into, listen to this carefully, it will be R21 cap, meaning if it is 1 2 here, here it will be 2 1. Okay. In a similar way, so what is actually F12? It is the force experienced by particle 1 due to 2. Okay. Similarly, when I take F21 vector, that will be equal to G M1 M2 divided by R square into R12 cap. See, this is a very, very important thing to be kept in your mind. So this is what we call as vector form of law of gravitation. Okay. Now see, having this in mind, see if you have noted down, I'll proceed. Are you done copying it? So F12, I have already told. What is F21? F21 is called as the force experienced by second particle due to 1. Okay. So having said this, we will try to understand another important concept called as principle of superposition of gravitational forces. Okay. So the statement for this principle of superposition goes like this. So according to the principle of superposition, the gravitational force between two masses. So when I talk about the gravitational force between two masses, acts independently and uninfluenced by the presence of other bodies. Hence, if you have two systems present in the system, if you have two particles present in the system like M1 and M2, then it is possible for you to calculate the gravitational force between them as G M1 M2 divided by R square. Am I right? But what if there are multiple particles present in the system? If there are multiple particles present in the system, then we need to go with the concept of principle of superposition. Okay. So I'll tell you what it exactly means. Listen to this carefully. Suppose I have three particles like this. Okay. Where this is M1, M2, and M3. Now I'm interested to calculate the force experienced by M3 due to M1 and M2. Right? What did I say? Force experienced by M3 due to M1 and M2. If I want to calculate it like that, right? Then listen to this. So the force between M1 and M2 is going to act along this line. Right? Okay. I'll make it simpler. Listen. So force between M1 and M2, sorry, M2 and M3 is going to be in this direction. So I'll call this as F32 vector. Similarly, the force between third and first particle is going to be F31 vector. Right? So if these two forces are acting at the same point, then the resultant force of these two, if I call this as Fr vector, then this is given as the vector sum of 3,1 plus the vector sum of 3,2. So the meaning of this is, when there are multiple forces present in the system, when there are multiple masses present in the system, then the force experienced by one of the masses due to the remaining system is going to be equal to the vector sum of the individual forces experienced by the particle due to the other particles. So listen to this carefully. So resultant gravitational force acting on a particle due to a number of masses is the vector sum of the gravitational forces exerted by the individual masses on the given particle. Okay. So this is how it works. Okay. Now, based on this, I'm going to give you a problem which you're going to do. Listen. There are 3 particles present at the vertices of an equilateral triangle M, M. So the masses present are M, M, and M. And the side of the equilateral triangle is A. Now, I have a 4th particle, capital M, placed at the centroid of the triangle. So capital M, where is it placed? It's placed at the centroid of the equilateral triangle. Right? When it is placed at the centroid of the equilateral triangle, calculate the force experienced by capital M due to the remaining masses. Okay. So how to proceed? So if I take this to be A, B, and C, right? So if I call this as G, then the force between AG will act in this direction. So force experienced by, I need to write the force experienced by G due to A. So FGA will be in this direction. FGB will be in this direction. And FGC will be in this direction. So what is going to be the force experienced by the particle at G due to A? Let me call out a name and ask. Hari Raghav.
Sir,
So what is the value of force experienced between small m and capital M? So I gave you the formula already. F is equal to G
M1
M1
into
R square, right? So here it is going to be capital G into what is M1 small m
Sir,
and what?
sir, small m will be A and M2 will be B.
Okay. So small m into capital M divided by what is the distance between the vertex and the centroid? Shri Kriti.
Sir, we need to apply trigonometry and find out.
How much will the value come out to be?
Sir,
Say this
1
is going
minute.
to be, yeah.
Sir, is it A by root 3?
Yes, it is A by root. So you will have G M1 into capital M into A by root 3 the whole square. The training. One minute, wait. Device got stuck. Yeah. So G small m into capital M divided by A by root 3 the whole square. So this will be equal to 3 GM into M divided by A square. Am I right? Similarly, what is going to be the magnitude of FGB? It will be same 3GM into capital M divided by A square. Then what is going to be the magnitude of FGC? That will be 3GM into capital M divided by A square. Now the question is at point G. So this will be FGA, this will be FGB, and this will be FGC. So if this angle is going to be 120 degree, this will also be 120, and this will also be 120 degrees. So can I say FGA is equal to FGB is equal to FGC is equal to F? Can I say like this? Right? So when that is the case, I'll have one force like this, the other force like this, and the third force in this way, where these two forces can be resolved into two components like this one can be resolved. See, this is going to be 30 degrees. This is also going to be 30 degrees. So this will be F cos 30 and this will be F sin 30. Okay. Similarly, this will be F cos 30 and this will be F sin 30. Right. So F cos 30 and F cos 30 will get cancelled. There is an upward force of F acting and downward force of how much acting? F by 2 and F by 2. So why I wrote F by 2 is because sine 30 is half. So F by 2 plus F by 2 is going to be F in the downward direction and capital F is already acting in the upward direction. So the net force acting on this particle is going to be 0. So the force experienced by the charge at centroid is 0. Is it clear? So this is how you solve problem based on principle of superposition. Okay. Social theorem not needed. Now we will do some problems based on Newton's law of gravitation and principle of superposition. So try out the first one and tell me what is the answer. 2 minutes time. Do it fast. Calculate the force of attraction between two balls, each of mass 1 kilogram, when their centers are 10 centimeter apart. Given the value of capital G is 6.67 into 10 power minus 11. So you should have got the answer by now. It is very simple. How much is it? F is equal to
6.67 into 10 power minus 9.
yes. So 6.67 into 10 power minus 7 into 1 divided by 10 centimeter is 0.1 meter. So it is going to be 10 power minus 1 the whole square. So it will be 6.67 into 10 power minus 9. Correct. Okay. So do this one. Answer. So I just took that 1.99 approximated to 2 so that it's easy for me. Divided by 7.8 into 7.8 into 10 power 22. So answer should be somewhere around this value. Okay. So 4.145 into 10 power 23 Newton. Now what they told is, assuming that Jupiter moves in circular orbit around the sun, calculate the speed of the Jupiter. So gravitational force should be equal to mv square divided by r. Okay, which implies v will be equal to root into rf divided by m, where r is going to be this value 7.8 into 10 power 11 into the force is 4.415 into 10 power 3, the whole divided by m. So what is going to be the value of m? It will be 1.9 into 10 power 27. So when we substitute all these values and calculate, we'll get 1.304 into 10 power 4 meter per second. Okay. So one last problem based on gravitational force. Yeah. So try this. Two particles each of mass m go around a circle of radius r under the action of their mutual gravitation. Find the speed of each particle. What is the answer? proceed to the next concept. I don't know if you guys are doing also. Or at least complete the portions and give you. So write down the next heading as acceleration due to gravity.
Sir,
Tell me.
in the previous question, what should be the distance between those two particles?
So read the question. Two particles each of mass m go round a circle of radius r, right? So if this is m and this is m, you cannot take the distance between them to be r, because if this is going in a circular path of radius r, then this will act as the center. If this is going in the circular path, then this will act as the center. If you observe, they both are independently revolving. So that cannot happen. So in order to ensure that they are revolving in a circular path, then the distance of separation between them should be equal to 2r. So that they both revolve in a circle of radius r.
Okay, sir.
Okay. So what will be the answer? M into v square divided by r will be equal to g into m square divided by 4r square. So r and r will get cancelled, m and m will get cancelled. It will be root of gm divided by 4r. Understood?
Yes, sir.
Maybe I'm moving to the next concept. Write down the heading. Acceleration due to gravity of the earth. So now our job is to write the expression for the acceleration due to gravity when the object is located above, below, or on the surface of the earth. Okay. So you know what is acceleration due to gravity? It is small g, right? Now listen. If I take this to be the center and r to be the radius, let's say the object is placed on the surface of the earth. Okay, let us assume that the object is placed on the surface of the earth. Then the weight experienced by the object is mg. So write down the heading as acceleration due to gravity when the object is on the surface. So mg will be equal to capital G into small m into capital M divided by r square. So m and m will get cancelled, which implies g will be equal to capital G into m divided by r square. So this is going to be the acceleration due to gravity when the object is placed on the surface of the earth. Okay. So when you substitute the value of capital G, wait, it's not right. So G is equal to capital G into M divided by R square. When you substitute the value of capital G, right, that is 6.67 into 10 power minus 11, and mass of the earth and radius of the earth. So mass of the earth is 6 into 10 power 24 kilogram, and the radius of the earth is 6.4 into 10 power 6 meter. Okay, that is 6,400 kilometer. If you substitute all these values and calculate the value of small g, So capital G is 6.67 into 10 power minus 11. Mass of the earth is going to be 6 into 10 power 24 kilogram, and radius of the earth will be 6,400 kilometers. Right? So when you substitute all these values and calculate, the value of G comes out to be 9.8 meter per second square. So this is going to be the value. Okay.
Yes, sir.
Right? This is the value of acceleration due to gravity when the object is on the surface of the earth. So I can say this is on the surface or close to the surface. Right? Okay. Next is write down the heading acceleration due to gravity at an altitude h. Okay. So this is R. So if I take the weight of the object here to be mg dash, why I'm taking it as g dash is because the acceleration due to gravity at a certain altitude is not going to be 9.8 meters per second square anymore. It will reduce. So mg dash is equal to capital G into capital M, that is mass of earth, into mass of the object divided by, remember that the mass of the earth is concentrated at the center, divided by R plus H the whole square. So what is going to be the value of G dash? So G dash will be equal to G into ME divided by R plus H the whole square, and this will be one of the expressions that we need to remember. Okay. So the next value is G dash is equal to G into ME divided by, if I take R outside, it becomes R square plus 1 by H the whole square. Now tell me, what is the GME divided by R square called as?
G.
Small g. So small g divided by 1 plus H by R the whole square. So what we can do is, we'll do one thing. This can be taken as 1. Okay, this is one of the values of small g dash. So g dash will be equal to G into 1 plus H by R the whole power minus 2. So this will be equal to G into 1 minus 2H by R if the value of H is very much less than R. Meaning, if the height is in terms of few meter, right, which is very small compared to the radius of the earth, which is 6,400 kilometer, right, when it is going to be that less, then you can apply this formula to solve the problem. So these two are the expressions for acceleration due to gravity as a function of altitude. Okay, is this point clear? No?
Sir,
Yeah, tell me.
sir, that one plus h by r power minus 2, then how did you get that 1 minus 2 h by r?
That's called binomial theorem. So if 1 plus x the whole power n is there, it can be written as 1 plus nx if the magnitude of x is very much less than 1.
Okay, sir.
Okay. Okay. Now see. Now the next concept is acceleration due to gravity at depth d. Okay. So if I take this to be the earth, if I take this to be the earth, if I want to calculate the acceleration due to gravity at depth d. So when I say depth, it is measured below the surface, right? So this is the surface. So if the depth is measured below the surface, right, then what is going to be the acceleration due to gravity of this portion? So how to calculate it? If I take this to be the mass of earth, it is not going to be the mass of the earth that is going to get concentrated. So if I take a small portion d, right, if I take a small portion d, what is the radius of that portion? The radius of that portion will be equal to r minus d. And if I keep an object here, right, of mass m, then it will experience a weight in the downward direction as mg double dash. Am I right? Now, this mg double dash is to be provided by the gravitational force, that is g into mass of the earth dash. I'll tell you why I wrote dash. Okay, into mass of the earth divided by r minus d the whole square. Why I wrote it as me dash is because in the previous two scenarios, the total mass of the earth was acting on the object. Whereas in this case, since the object is kept at a depth d, right, only a portion of the mass of the earth is going to pull it towards its center, right? So for that, I need to calculate the density. So density is equal to how much? Mass of the earth divided by 4 by 3 pi r cube. Right, mass of the earth divided by 4 by 3 pi r cube. So what is going to be the density of the smaller portion? It's still going to be rho only, but this time it is me dash divided by 4 by 3 pi into r minus d the whole cube. Right, now if you equate these two, if you equate these two expressions, that is me divided by 4 by 3 pi r cube is equal to me dash divided by 4 by 3 pi into r minus d the whole cube. So 4 by 3 pi is gone. So me dash will be equal to m into e multiplied with r minus d the whole cube divided by r cube. Okay. So if I take this to be the first expression, this will be the second one. We'll plug the value of 2 in 1. So till here, copy it. Right. So using 2 in 1, what do we get? We get mg double dash is equal to capital G into mass of earth into r minus d the whole cube divided by r cube multiplied with small m. So m and m will get cancelled. G double dash will be equal to GME divided by r square into, I'll take this r cube outside. R cube is 1 minus d by r the whole cube, the whole divided by r. Okay, I'll do one thing. So it will be GME into r minus d divided by r the whole cube. So can I write this as GME into 1 minus d by r the whole cube? So this is going to be the value of G double dash. Okay. Done?
Yes, sir.
Okay. So now we'll do some problems based on these concepts. Try this. So at what height above the Earth's surface the value of g is half of its own value, given its radius is 6,400 kilometers. So at what height above the Earth's surface, here the acceleration due to gravity is g by 2, right? So what is the formula? G at height h is equal to small g into r by r plus h the whole square, right? So here it is going to be g by 2 is equal to g into r by r plus h the whole square. So g and g will get cancelled. R divided by r plus h is equal to 1 by root 2. So root 2 r is equal to r plus h. So root 2 minus 1 into r is h. So this will be the answer. Okay. Next is find the percentage decrease in the weight of an object when it is taken to a height of 32 kilometers. Here, if you observe, 32 is less than 6,400. So we can apply that approximation. GH will be equal to G into 1 minus 2H divided by R. Okay. So for us to calculate the percentage decrease, so what we'll do is we'll write GH is equal to G minus 2H into G divided by R. So GH minus G, sorry, G minus GH will be equal to 2H into G divided by R. So I'm taking the GH to the left hand side and 2H by G to the right hand side. So if I take this G to the denominator, G minus GH divided by G is equal to 2H by R. So this will give me the fractional decrease. So the fractional decrease multiplied with 100 will give me the percentage decrease. Okay. So it is going to be 2 into h divided by r multiplied with 100. So 2 into height is 32 divided by the radius is going to be 6400 into 100. So 0, 0, it is going to be 1%. Is it clear? Is it clear or not?
Sir, can you explain once?
Listen. The object is taken to a height of 32 kilometers, right? We need to find the percentage decrease in acceleration due to gravity. Okay. So when I say percentage decrease, listen to this carefully. It is always final minus initial, final minus initial divided by initial into 100. Okay. So final value is going to be, actually I'll change it. So instead of calling it as decrease, no, I'll call it as percentage change. Okay. So percentage change is given as final minus initial divided by initial. So final is GH minus G divided by G into 100 will give me the percentage change. So if this comes out to be negative, it is decrease. If it comes out to be positive, it is going to be increase. Okay. So what is the value of GH they have given? We don't know. So what I'll do is, I'll take the expression GH is equal to G into 1 minus 2H into, 1 minus 2H divided by R. Is this step clear? Why did I apply this? Because 32 is less than 6400. Is it right?
Yes, sir.
So GH will be equal to, multiply the G with each term. So G minus 2H into G divided by R, which implies GH minus G is equal to minus 2H into G divided by R. So if I push the minus sign this side, G minus GH divided by, I'll take this G to the left hand side, by small g will be equal to 2H by R. Is this expression clear?
Yes, sir.
Okay. Now, if you see, this is initial, this is final divided by initial. So, if it is final minus initial by initial, it is change. Okay. So, if this value comes out to be positive, it is going to be increase. But here, if you see, I reverse the value. I wrote it as initial minus final divided by initial. So, this is going to be decreased value. And this decreased value is not percentage, rather it is fraction. So it is called as fractional decrease. So fractional decrease is 2H by R. So if I want percentage decrease, what should I do? Multiply with 100 on both the sides. So when you do this, then this value will become percentage decrease. Is the point clear? So that will be 2h by r into 100. So 2 into what is the value of height? 32 divided by r is 6400 into 100. These two zeros, they will get cancelled. 64 by 64 is going to give us 1%. Is it clear now?
Yes, sir. Understood. Sir.
Good. So make a note of this. And with this, we'll wind up. Okay. Remaining problems we'll do tomorrow. So let me know once you're done copying.
So can you scroll up? Yes, sir.
Sir,
Tell me.
can you once show that acceleration due to gravity at depth d, that derivation?
It's here.
Sir, in that using 2 in 1, sir, I think you missed that r minus d whole square, sir, in the denominator.
Did I? This one,
No, sir,
okay.
the down. Yes.
And this one, no? Yeah. Okay, if that is the case, 1 minute. I'll write it again. Guys, copy it. So mg double dash is equal to g into me into r minus d the whole cube divided by r cube into small m divided by r minus d the whole square. Right? This and this will get cancelled. So m and m are gone. G double dash will be equal to g into me divided by r square into r minus d divided by r. Did you understand what I did? This r cube, I split it as r square into r. So what is the GME divided by r square? It is going to be small g into, this will be 1 minus d divided by r. Clear? Is it clear? Okay, we'll wind up.
Thank you, sir. Thank you, sir.
Thank you, sir.